Hey Algebra 1, today we're going to continue our discussion on how to solve literal equations by looking at a couple special cases as well as a couple more difficult problems. For the warm-up that you see on the screen here that you should have seen in their hyperdoc, the solutions you should have for x are the following. For the first example, for x minus y equals 4, you should have x equals 4 plus y. And then for the second example, you should have x equals 6 plus y divided by 2. Okay? Make sure you're checking those answers. Make sure you message me if you don't understand how I got them. Let's go ahead and get started here. So in these four examples, go ahead and write these down. Pause the video right now. Give yourself some time. Write down these four equations. With these four, we have a couple of examples where x is in the numerator of a fraction and where x is in the denominator of a fraction. I'm going to start with x divided by 3 equals y, the second equation right here. Okay? Because this is one we know how to solve already. So all we have to do, because we have x divided by 3 equals y, we have to apply our multiplication property of equality. So I'm going to multiply both sides of the equation by 3. That allows me to cancel out my 3's on the left side because there's no need for them, and I'm left with x is equal to y times 3, or just 3y. Simple example to start with. Okay. On the other side of this, on the left side here, we have something very similar, but not exactly the same problem. We have, instead of x divided by 3, we have 3 divided by x is equal to y. The process is still the same. We want to multiply by what's in the denominator to get it out of there. So I'm going to start by multiplying by x, which is what we're solving for. We're trying to get x by itself here. When that happens, once again, just like the 3's in the other example that we just did, the x's will cancel. I'm left with 3 is equal to y times x. Now remember, we're trying to solve for x here. Okay? So I want to go ahead and also divide by y, because that's the one non-x term I have left. And so once again, just like the line above, my y's cancel. I'm left with 3 divided by y, and there's my definition for x. So I can rewrite it as x equals 3 divided by y. Okay? So we want to be able to pick up on this pattern for more complicated problems, like we see in example 3 right here, which is x divided by 3 minus 3 is equal to y. For this one, just like any other example where we would have addition or subtraction, I want to go ahead and make sure that there are no addition or subtraction signs left by using their opposite operations or inverse operations. So my first step is going to be add 3 to both sides of the equation. So plus 3 plus 3. My 3's are going to cancel. And because y and 3 are not like terms, I'm going to write it as just y plus 3. And I'm left with just my x divided by 3 here. Okay. Now, just like we saw in example 2, I'm going to go ahead and solve this equation by multiplying by 3. But here's something we have to remember. This y plus 3 on the right side here, this is considered a number. So I don't want to leave any part of this out. So I'm going to be putting parentheses around it, because we want to group that together to recognize that it is one number. So just like before, my 3's cancel on the left side, I'm left with x here, and then I also have y plus 3 here. So 3 times y plus 3. And this is an acceptable answer. Some of you may say, hey, well, there's a 3 outside my parentheses. I should be distributing. You're absolutely correct. So when I do that, y times 3 and then 3 times 3, that gives me x equals 3y plus 9. So once again, either answer is acceptable if you want to leave it factored or if you want to distribute out, but that is how you solve for x given this more complicated example. And of course, as you probably could have guessed, we're going to be moving on to when we have an equation where the variable we're solving for is in the denominator. So start it the same exact way. I'm going to add 3 to both sides of the equation. Make life a little bit easier here. 3's cancel. Leave this as y plus 3. and then we get 3 over x back on the left side. Now the process is the same again, just like it was in the previous 3 examples. I want to dig out my variable from the denominator by multiplying by x. And then once again, we want to recognize that y plus 3 is a number because it's the sum of numbers. And x's are going to cancel like before. I'm left with 3 here, and then y plus 3 times x. Now the nice thing about y plus 3 being its own number is that I can go ahead and treat it like that. If this were any number besides y plus 3, if we had a value for y that we could substitute in and just get a single number, this would make everything so much easier. But because we don't have a variable for y, or a value for y, I'm just going to go ahead and divide by y plus 3 on both sides. And in this case, I'm left with 3 divided by y plus 3 as my solution for x. Okay, so once again, take a look at what's going on with the variable that we're solving for, as well as where its position is in the equation. Okay, make sure you take a look at part 2. We'll get into 2 simpler examples after this video is done.